Why does a football inflate and become firm? Why does a deodorant can feel cold when you spray it? And why does heating a gas make it expand instantly? All of this comes from one idea. Gases are just tiny particles flying around like crazy. Take an empty plastic bottle, squeeze it hard, then release it. Hear that popping sound as it returns to shape? That's the air inside pushing back, not because air is strong, but because its particles are constantly hitting the walls. That's the entire kinetic theory in one moment. This is the learning studio where we explain complex science with clean, clear logic. In the kinetic theory of gases, a gas is nothing but millions of tiny particles moving randomly, hitting everything, bouncing off each other. Three core ideas matter. Particles are always moving. Faster when hot, slower when cold. Gas pressure comes from collisions. Every time particles hit the container walls, they push outward. More hits, more pressure. Temperature is just the average kinetic energy. Hotter gas, faster particles, higher energy. That's why heating a gas increases pressure, and cooling it reduces pressure. There's one term that teachers love, but students ignore: mean free path, the average distance a gas particle travels before bumping into another. In solids, almost zero, particles packed. In liquids, small. In gases, huge. That's why gases spread quickly and fill any container. Now, the gas laws suddenly make sense. Boyle's law: P when V, more space, fewer collisions, lower pressure. Charles' law: V hats when T, heat, faster particles, they push walls, gas expands. Gay-Lussac's law: P when T, heat without giving space, pressure shoots up. Avogadro's law: more particles, more volume, double the particles, double the collisions, double the space needed. Every gas law is just particle behavior written mathematically. Real-life examples you can't ignore. When tires heat up on a highway, pressure increases. Spray deodorant feels cold, gas expands and cools instantly. A balloon left in the sun expands. A football deflates in winter because particles move slower. Pressure cookers cook faster because hotter gases hit harder. Gases behave logically once you see them as tiny moving bullets. Now here's something to think about. If all gases are just particles flying around, why does air, which feels so light, create hurricanes, storms, and massive pressure systems? The answer connects directly to fluid dynamics, and we'll break it next.